Hi there. This video is going to deal with the topic biodiversity for Module 2, CCEA Module 2. I previously have done videos on adaptations and distribution, and I also have a video on human impact on biodiversity, and both of those are available as well. This one's going to be on biodiversity. To get most benefit from this video, you need access to a set of my notes and a set of past paper questions, both of which you can obtain if you get in touch with me. That's my mobile number there. I will be making constant reference to the notes and to page numbers, and also making reference to questions. So you need the questions and the notes in front of you to benefit completely from this. Okay, this topic is looking at biodiversity. Biodiversity, in simple terms, just the range of living organisms that would be present in a habitat or an environment. And we're going to look at how organisms are classified into groups, and look at the 5 kingdom system, as it's called. We're also going to look at Simpson's Index, which is a measure of biodiversity. And we'll start then with just to say that it's thought that there are some 90 million species of different organisms present on this planet, in the region of 90 million. The figure is disputed, but it's somewhere in that sort of ballpark region. So 90 million different species, different organisms. It's sometime or other you get asked then, what do you mean by the term species? Different species. So for example, dogs are a species, cats are a species. What exactly is the definition of a species? And you often get asked that definition. If you look at question 1b, the question asks, how do you know if 2 organisms are the same species? Well, the answer is species is a group of organisms that are all similar and are able to mate with each other and able to breed with each other to produce fertile offspring. So they must be able to produce offspring. These two organisms are the ones, same species. They must be able to breed with each other to produce offspring, and the offspring themselves must be fertile. In other words, the offspring in turn must be able to produce more offspring. And so, for example, all horses would be the one species. Horses can all breed with each other and produce more horses. Same with dogs and cats and so on. 2 organisms that aren't the same species would be horses and donkeys, just to give an illustration. They can still breed with each other and produce something called a mule, but the mule is not itself fertile. In other words, the mule cannot go on and produce more mules. To get more mules, you have to go back to the horse and the donkey. So that's sort of outlining the idea of species. And there are then, as I've said, somewhere in the region of 90 million different species on this planet. Now we come to the matter of trying to classify these species. And in recent times, scientists have agreed that all these species can be grouped together into 5 big groupings called kingdoms, the so-called 5 kingdom classification system, 5 kingdoms. And the 5 kingdoms are animals, plants, fungi, prokaryote, and protoctista, 5 different kingdoms. And you occasionally get asked about these kingdoms then and asked to discuss them. Classic question of question 14, where it asked you in an essay question, it said, describe the main features of organisms in each of the 5 kingdoms. Describe the main features of the organisms in each of the 5 kingdoms. Now, I set that out for you on pages 3, 4, 5, and 6. And I'm especially looking there on page 6 at the table, where I've got a table that allows you to compare the 5 kingdoms on the basis of different features. And I make note in an earlier page there, on page 3, I discuss some of the features that I'm using to compare the organisms of the 5 kingdoms. So I'm using terms like unicellular or multicellular. Unicellular means organisms of just one cell. Multicellular are organisms with many cells. Autotrophic nutrition and heterotrophic nutrition. Autotrophic nutrition means feeding yourself, providing your own food, and essentially that refers, as far as you're concerned, to photosynthesis. So autotrophic nutrition is photosynthesis, and that of course relates to plants. Heterotrophic nutrition is as the word suggests, hetero, getting food from others. And that's essentially what we do, feeding on others, heterotrophic nutrition. And that essentially applies to ourselves, animals, but also applies to fungi. Um, Other aspects of interest there are to do with the DNA, and do with an organism's DNA, whether it's linear or circular. Just to say that linear DNA would refer to the kind of DNA that we have, where the DNA molecule is a long slender molecule, a linear molecule that you might find, for example, wrapped onto a chromosome. So I'm illustrating here just what a chromosome, essentially what a chromosome, in essence what a chromosome is. A chromosome is a structure that allows you to store your DNA. So essentially our DNA is said to be linear DNA. The other example of DNA that you come across there is circular DNA, and circular DNA refers to plasmids essentially. Well, for your purposes, plasmids, and if you remember plasmids, were circular loops of DNA found in bacteria are prokaryotic cells. So those are the main features that I want to look at in relation to the five kingdoms. So the five kingdoms, as we said, are five big groupings into which all the living organisms on this planet are placed. And on page 6 there, you can see I've got a table that tries to summarize the main features. And those main features then would, that summary on page 6 then would help you to answer question 14, which is an essay question giving you 8 marks, asking you to describe the main features of the five kingdoms. And you'll easily get 8 marks from that table. Also refer you to question 12 in the question booklet there, which is just a question I've created. And it allows you to, once you feel you understand the five kingdoms, or you know the main details of the five kingdoms, you can then practice filling in that table. And you see the first element there in the table is the idea of whether the organism contains cells that are prokaryotic or eukaryotic. Well, the first group on the top, first kingdom there on the list is prokaryote, and they're called prokaryote because their cells are prokaryotic. And essentially, as far as you're concerned, that's bacteria. So if you want to write bacteria in there on the prokaryote, that's the bacteria. And then after that, you can write they're prokaryotic, PRO, I've just got in the notes here, prokaryotic. If you also want to write there, opposite the prokaryote, you can write circular DNA, because they've got circular DNA. All the other groups, Protoctista, fungi, plants, and animals, they are eukaryotic. In other words, they contain a nucleus and organelles. And inside the nucleus, they have chromosomes, and the chromosomes have DNA wrapped onto them, or they would have chromosomes and linear DNA. So for each of the others, for Protoctista, fungi, plants, and animals, under the prokaryotic, eukaryotic column there, you could write they're all eukaryotic. EU would do. And you can, if you want to, also say linear DNA, so all of linear DNA. Then the next column you see there, the next column I've got is unicellular or multicellular. Well, I'm going to start from the animals and the plants here, down to the bottom where the animals are there. Animals, to get into the animal kingdom, or the animal kingdom is designated as those animals that are multicellular. So you have to be multicellular to be put into that kingdom. Scientists have decided only to put multicellular animals into the kingdom animals. The same with plants. Get it be in the plant kingdom, you have to be multicellular. If you're a unicellular plant, you don't go into that group. Unicellular plants you've come across, and you might refer to them as algae. You came across algal bloom at GCSE. Algae are microscopic single cell plants. Now, if you're a single cell plant on algae, you don't go in the plant group. Don't go in the plant kingdom. You're put into another group called the Protoctista. Fungi then, essentially the fungi that you need to know about are essentially two. There's mushrooms. Mushrooms and they're multicellular fungi. And then you have unicellular fungi. Unicellular fungi would be yeasts. So under the heading, under unicellular, multicellular for the fungi, you could write multicellular, for example, for example, mushrooms, etc. Mushrooms, toadstools, and all those other things that look like mushrooms. And then you could write a unicellular, example, yeasts. And Protoctista is an odd group. Basically, Protoctista are an odd kingdom in the sense that It's a group that contains all the organisms that don't fit easily into the other four groups. Don't fit easily into the other four groups. So as we said, prokaryote, that's essentially bacteria. Fungi, we've said yeast and mushrooms. Animals and plants, well, we understand multicellular animals and multicellular plants. Protoctista contains any organism that doesn't fit neatly into any of the other groups. So into the Protoctista group, I've already said, goes unicellular plants, we might refer to as algae, unicellular. And also, I should have said unicellular animals. Unicellular animals and unicellular plants are found in water. So if you get water from a river or from the sea or from any area where we've got water, you'll always find look down the microscope, you'll see lots of microscopic animals and plants, and they're put into the group Protoctista. So under unicellular, multicellular, you would write mostly unicellular for the Protoctista. And the prokaryote, who are the bacteria, you can write unicellular. They're unicellular. Autotrophic or heterotrophic? Well, we'll start with the easy one here is plants. Plants are autotrophic, essentially photosynthesis. Animals are heterotrophic. We eat food, we get food from others. Fungi don't do photosynthesis, they are heterotrophic. They actually do a kind of nutrition called lysotrophic nutrition. Lysotrophic nutrition, now you'd learn about that in another topic, lysotrophic, O-P-H-I-C. Lysotrophic nutrition is an example of heterotrophic nutrition. And it's a form of nutrition, and just to illustrate, it's essentially what happens is, with a mushroom or a toadstool or such, what you find is, say you have a mushroom growing in some soil or in some compost or whatever, you find that in the compost, at the base of the mushroom, you'll find lots of like roots, and these roots are called hyphae, H-Y-P-H-I-E, hyphae. You'll learn about them in the cell topic as well. And what happens is that these hyphae secrete enzymes into whatever material the mushroom's growing on, into the soil or into compost or wherever you find the mushroom growing. And these enzymes break down whatever organic material is present where the mushroom's growing. They break down the large molecules in the organic material into small molecules. So if there's protein here, let's say this is soil. Soil contains the remnants of dead leaves, organic material, dead leaves, dead roots, dead plants, dead organisms. And these enzymes will break down the proteins into amino acids. And then the amino acids are small enough, the amino acids get absorbed into the hyphae and used then by the mushroom to grow. So this is lysotrophic nutrition, an example of heterotrophic nutrition. Bacteria are all heterotrophic as well. Well, there's some autotrophic ones, but they're mostly heterotrophic. Wherever you find bacteria, wherever they exist, they are feeding on their surroundings. So if you have bacteria, for example, on the surface of your skin or inside your digestive system, they're feeding on the contents of your digestive system or stuff on the surface of your skin. They are heterotrophic. Protoctista then, since the Protoctista is a mishmash of different things, animals and plants, you could say heterotrophic and autotrophic depending on what organism we're talking about. Cell walls is an interesting one there. You might say cell walls, but that's plants. That's plant cell walls. And you can go to plants and you can write plant cell, you can put a tick there, it's cell walls, and you can write cellulose. Okay, because plant cells have cell walls made of cellulose. Animals, they don't have cell walls, so put an X there. Fungi, well, interestingly, fungal cells have cell walls. Not made of cellulose, it's made of something called chitin, C-H-I-T-I-N. C-H-I-T-I-N. Pronounced chitin or chitin, whatever way you want to pronounce it. But they do have cell walls. Bacteria, prokaryote, also have cell walls. And depending on what textbook you look at or whose notes you have, the cell walls of bacteria, you could say, are made of glycoproteins or peptidoglycans is what I think I have in my notes, peptidoglycans. But they definitely have cell walls. And then the Protoctista, well, any plant cells that are in the Protoctista group, those plant cells will have cell walls. Okay. So that's cell walls. The last item there I just noticed on the table is energy storage carbohydrate. Energy storage carbohydrates, the two energy storage carbohydrates that you need to know about are glycogen and starch. And of course, straight away you can go to the plants, the plant kingdom, and you can write starch is the energy storage carbohydrate. In us animals, it's glycogen. In fungi, then it's glycogen as well. And in bacteria, it's glycogen. So note the pattern there, just remember, bacteria, prokaryotes, fungi, and animals all have glycogen as their energy storage compound. Plants have starch as their energy storage compound, and then of course the product test, depending on whether they're animal-based cells or plant-based cells, will have glycogen or starch. It will either have glycogen or starch. So there's a quick run through the table, run through that table, and what that table does is it gives you an overview of the 5 kingdoms, the 5 different groups into which all organisms are grouped, and it should easily answer the essay question. I think it's question 14 there, if you were asked anything about that. Now, other questions that tend to be about the 5 kingdoms would be question 1 and let's see what other questions there. I think there's a couple of questions. Question 7, question 11, question 12, question 14. Sorry, question 1. Let's have a look then at question 1 and question 13. Question 1 and question 13 are of this nature, where you have to, based on the statements available there, you have to decide which kingdom we're talking about. So we're going to look first of all have a look at the more recent question, which is question 13. And question 13 starts off, it says, DNA is usually linear. Well, once it mentions linear DNA, you're thinking of the eukaryotic groups. So that would be Protoctista, fungi, plants, and animals. If it says DNA is linear, no, that means it's not linear, that's circular DNA. So group A must be the prokaryotes, because they've got circular DNA in the form of plasmids, for example. They've got other circular pieces of DNA, but plasmids is the one that you might remember from GCSE. So A is prokaryotes. Then you go down to most members are unicellular. Well, you've already eliminated the prokaryotes, so they're gone. So what's left then? Well, the Protoctista are mostly unicellular. There are some multicellular examples, and we'll come and look at those in a minute or two, but they're mostly unicellular. So mostly unicellular, yes. B then would be Protoctista. And notice that the two kingdoms you've just got rid of or dismissed already are Prokaryote and Protoctista, and that's frequently the way with these questions, is that the system gets rid of those two first of all. Then we're down to most cells are unicellular. No, that's leaving us just then with the fungi, the plants, and the animals. And then it comes down then, cells have many nuclei. Well, that's something you might want to write on your table, because that's a characteristic feature of fungi. Fungal cells are multinucleate, and you might know that from the cell topic as well. So you want to write that onto the table, even in the notes there. Fungal cells, multinucleate, many nucleases. So if you say yes, then C is fungi. If you say no, then you're talking plants and animals. Feeding is always heterotrophic. You say yes, that's D, that's animals. And that leaves E to be plants then. E is plants. Now, that's that one, pretty straightforward. One on the front page here, quite similar. Starts off the 5 kingdoms. Members of this kingdom have cells with a nucleus and membrane-bound organelles. Well, that definition, kingdoms have cells with nucleus and membrane-bound organelles, that means eukaryotic. So if you say no, then A has to be the prokaryote, prokaryotes or prokaryote, basically the bacteria. So A is the prokaryotes. Then you go down, members of these kingdoms may use autotrophic nutrition. May use autotrophic nutrition. Well, you're thinking straight away autotrophic nutrition, that's plants. Oh, but it may also be the Protoctista, because there are many examples of plant cells in the Protoctista. So if you say yes, then it goes down and says, members of this kingdom are unicellular or show limited cell differentiation. Well, you basically have down the left there to the left-hand side, you either have plants or Protoctista. members of this kingdom are unicellular. Well, that suggests that's the Protoctista. So if you say yes, then that's yes, and that's B is Protoctista, and C then would be plants. So B would be Protoctista, and C would be plants. I'll talk about the limited cell differentiation thing in a minute or two. You'd said no in the previous, you'd said members of this kingdom use autotrophic nutrition. You've said no, that means heterotrophic nutrition. That brings you down to the bottom there on the right hand side. It says members of this kingdom have cell walls made of chitin. So that's, and you say yes, that's D, that's the fungi, and E then must be animals. Okay, just want to do with one other thing there. That bit, if you go back halfway up the page, it said members of this kingdom are unicellular or show limited cell differentiation. That limited cell differentiation, that's referring to the Protoctista. And this is a commonly asked question because we've said here that the Protoctista are mostly unicellular, but there's a very clear situation where you've got a multicellular plant, what would appear to be a multicellular plant in the Protoctista group, and that is seaweeds. And seaweeds are often referred to as algae. Seaweeds would on the face of it appear to be multicellular plants found at the seashore. Multicellular, they're certainly plants. You would think they're multicellular, so why don't they go in the kingdom plants? Well, they don't go in the kingdom plants for that reason there, that they show limited cell differentiation. And just to see what that means, I'm just looking in the notes here to see if there's any reference to that. There's some reference somewhere. On pages 4 and 5 you can see some dealt with all the aspects of the kingdoms there. But limited cell differentiation refers to this. If you compare seaweeds with normal land plants, if you compare the leaves of the seaweed are actually referred to as fronds. And if you compare their leaves with the leaves of normal land plants, you find that the leaves of normal land plants are very sophisticated in terms of the numbers of different layers of tissue that are present. So going back even to GCSE, you knew that there was the waxy cuticle, then you had the upper epidermis, then you had the palisade layer, then you had spongy mesophyll cells and lower epidermal cells, and all those lots of different layers and lots of different tissues. And having all those different kinds of tissues, that's referred to as tissue differentiation. Lots of differentiation present within the leaf. Now, however, if you compare that leaf with a seaweed frond or seaweed leaf, you find that it lacks that kind of differentiation. You don't find all those different layers of cells that you would find in a normal leaf. Seaweed leaves tend to be less well evolved and less well adapted, and they lack all those different layers. So that for that reason, seaweeds are banished, as it were, from the plant kingdom and made to be in the kingdom Protoctista. And frequently get questions about that, about why the algae are in the kingdom Protoctista. I'm just looking for a question about that. Then there's a question somewhere relates to that. It's question 7. Question 7 part 7 part E. I think that question's been cut and bits of that question have been left behind. It says algae are now classified as Protoctista instead of plants, but not all scientists agree with this. Algae, in this case, is referring to seaweeds. Seaweeds, it says, are autotrophic and they are eukaryotic cells. With cell walls, they're also got tissues, but they show limited cell differentiation. Suggest one reason why scientists think it's more appropriate to include seaweeds in the plant group. Well, you could say they're multicellular. Is a good, and they're only getting 1 mark there, it says multicellular. Suggest one reason why scientists think it's not appropriate to include algae in the plant group. And the answer is these algae or seaweeds, they lack tissue differentiation, like differentiation in tissues. So that's that question. That question gets asked fairly often. Okay. All right. So that's the basis of the 5 kingdom classification system. The details are all there in the notes on pages 4, 5, 6, and 7. Now, we need to move on then to look at how each of the kingdoms then is divided into smaller groups. So we've got the 5 big groups, which are the 5 kingdoms. Each of those kingdoms then can be classified or split into smaller groups. So for example, if you say the kingdom animals, well, it's obvious that there are millions of different animal species on the planet, and you have to sort of come up with some sort of groupings for those. And the next grouping in the sequence below kingdom is the grouping which is referred to as phyla, P-H-Y-L-A, P-H-Y-L-A. The singular is phylum, P-H-Y-L-U-M. And just to give you an illustration, the animal kingdom contains in the region of 30 different phyla, 30 different subgroups, as it were, 30 different phyla. Just to give an example, human phyla is called chordata. Other examples would be insecta, that would be insects, annelida, that would be spiders, annelida would be worms, arachnida would be spiders, and so on. And there are 30 different phyla within the animal kingdom. So that's the next grouping down. Then each phyla then once again is split into different groups. And the groups then that the phyla is split into are called classes. So you have kingdom at the top, the big group, then you have many phyla, and each phyla is split into many classes. And then each class is split into smaller groups called orders. And then each order then is split into smaller groups called families. And then each family is split into smaller groups which are referred to as genera, G-E-N-E-R-A, which is the plural, each one being a genus. And then each genus contains then many different species. And that's the complete, as it were, classification, the complete sequence of classification categories used to classify any organism. So you have to, as a student, you have to remember the order of those. So the order is K, kingdom, phylum, KP, C, class, order, family, genus, and species. So if you want to just, as an illustration there, this is dealt with on page 7 in the notes there. As an illustration, if you want to go to page 8, you'll see how humans are classified. Human beings are classified. So the kingdom for us would be animals. Then our phylum is chordata. By the way, you don't have to remember we don't have to remember the names of the groupings here. You just have to remember kingdom, K, P, C, O, F, G, S, kingdom, phylum, class, order, family, genus, and species. One skill that I know of uses a way of remembering this. Keep ponds clean or frogs get sick. Just a way to remember it. K, P, C, O, F, G, S. So humans, going back to humans, humans are kingdom, animal, animalia, phylum, chordata, class, mammalia, order, primates, family, Hominidae, and then our genus is Homo, and our species is Sapiens, Homo sapiens. Now, when you come to name any particular species, if you say, how are we going to name a species, humans, using these kind of terminology, you'll use the last two steps here. You say that humans are Homo sapiens, and the same with every other species. You use this, as it were, a double-barreled name, and this is called binomial nomenclature. And if you were asked, what do you understand by the term binomial nomenclature? And the answer is, it's the naming of a species using its genus name and its species name. Genus name and species name. And I've given some other examples there. Lions are Panthera leo. Tigers are Panthera tigris. You can see that lions and tigers both are Panthera, that's their genus. That means they're quite closely related because they're in the same genus. And that's the same with plants as well. I've just given one example of an oak tree there, Quercus robur, and so on and so forth. And on page 9 there is just a wee illustration to show a number of different types of cats. And you see there that cats are these 4 cats have got the domestic cat, wild cat, lion, and tiger. And you see they're all in the same kingdom, Animalia. They're all chordata. Chordata essentially means they've got backbones, and they're vertebrates, as they used to be called. They've got backbones. In a class, Mammalia, they're all mammals. They have young and they suckle their young. The carnivora is their order. Carnivora suggests like they eat meat. And then their family is Felidae, which is the cat family. And then genus. Some of them are genus Felis and some of them are genus Panther. You'll see there that the domestic cat and the wild cat are genus Felis, and the lion and the tiger are genus Panthera. When two organisms share the same genus, that means they're more closely related. So, for example, the domestic cat and the wild cat are closely related. They're more closely related to each other than lions and tigers. This system of classification, this complete system of classification, sometimes known as phylogenetic classification, and it means that the system puts organisms into groups when they have a common ancestor. And in the past, you have been asked that definition. What's the term phylogenetic classification mean? So you need to know that term. Okay. All right. So kinds of questions you get asked on this. Question 1b there. You can see question 1b. They're asking you to fill in the boxes there. So at the top, on the left, you have kingdom, then it's phylum, class, and then under class you have order. And then over to the right hand side, kingdom. So we're talking about a butterfly, and kingdom would be animals, and you can see their phylum is arthropoda, and their class is insecta. And then their order is Lepidoptera. Now, how do you fill in the rest of that? Then you have 3 more boxes to fill there. Well, what you do is you go up to the top, and it says the speckled wood butterfly, and it gives its name Paragyra Egeria. Well, the Paragyra, that's its genus, and the Egeria is its species. So those go in the 2 bottom box. So the genus is Paragyra, and the species is Egeria. And then the family, if you go up and read in the text there, you'll see into a group of related genera called Nymphalidae, and that's the family. Because you'll see that occasionally they do ask this. They'll ask you definitions of the term kingdom, phylum, class, order, family, genus, and species. You see a lot of definitions there at the top of page 8. So, for example, if they ask you what is an order, you would say it's a group containing many similar families. And if they ask you what's a family, it's a group containing many similar genera, and so on. You see, it's quite simple answer then. So that's question 1b. Other one there, question 5. Just looking at question 5, it's the same sort of thing. In that case, you don't have to fill in the boxes there. They're filled in for you. And question 10, just having a quick look at question 10. Not going to be able to do all of these questions, but doing some of them. Question 10, then you sort of see, it says, in the context of classification, define the term order, KPCOF. Order would be a taxonomic grouping containing many similar families. So a group containing many similar families. And then you sort of see the way it's illustrated there. At the very outside, you'd have kingdom, and you have phylum Chordata, KP, C, and 2 would be class, and 3 would be order. And there you go. You have to fill those in. Now, let's just look at other bits and pieces here that we need to look at in this topic. And I'm trying to sequence it as best I can. Just looking at questions there. Question 2C part 1. Question 2, just generally looking at question 2, 3 features of the kingdom's prokaryote. 3 features of the kingdom prokaryote. You would say they have their cells lack nucleuses and organelles. They are unicellular, and the cells contain, for example, the stored carbohydrate glycogen would work for that. State the term for a group of similar and closely related species. That's genus. And then down here, see part 1 is a common question. Cell structure is one source of evidence used to classify organisms. So just going to the very front page of the notes here, it's discussing how you go about deciding whether organisms should be in the same group, whether organisms should be in 2 organisms should be in the same group. So, for example, how How is it decided that seals and dolphins and whales are all closely related or in similar groups to humans? Turns out they're all mammals. And that's one aspect, but there's lots of other features that allow us to, when you're comparing organisms, to decide if they are, as it were, closely related and should be in the same groups. And you see on page 1 there, features that you would use, and this relates to question 2C part 1. It says cell structures, one source of evidence used to classify organisms. Classify organisms means put them in groups. State other sources, so you could say anatomy, that's bone structure, or biochemistry, that relates to the biochemical processes that are happening inside the organisms. Or even just morphology. Morphology refers to external appearance, such as the presence of wings or tails or antennas, that sort of thing. So that question gets asked quite frequently. Now, I think I want to now look at Simpson's index. Simpson's index in this topic, and there may be bits of that topic that I need to come back on, other bits and pieces that I need to look at, but I'm going to do Simpson's index first of all. So Simpson's index is a calculation that can be done for a habitat or an area that gives you a measure of biodiversity in the particular area. It gives you a measure of the range of different species that are present in that particular area, and I deal with that in the notes on page 14 and page 50. So I'm going to deal with Simpson's index first of all, and then there's one or two other bits and pieces. I'll come back at the end if I have time on this topic. Biodiversity. The symbol for Simpson's index is D, and you can see the formula there to calculate. Now, in older questions, they would have done quite a bit of the calculation for you and just left you to do the final bit of the calculation. So older questions, for example, would be questions. Question 3 would be a somewhat older question where they've done most of the calculation for you and left you to do the last bit of it. Question 6 is probably the most recent question in this, and question 9 is an older question too. So it's always useful to practice doing calculations. I'm just going to look here at question 6 because it's the most recent question and it's most typical, and it gives you the formula for Simpson's index. So essentially, to get the Simpson's index value. Well, let's say you're asked to go to a wooded area, say a forest, and obtain a value for Simpson's index for trees in that wood. So what would you have to do? What kind of information you have to collect? Essentially, you need to be able to identify all the different types of trees there. So let's say you identified 5 different types of trees in the forest. Then essentially what you're doing is you have to count the number of each type of tree. So essentially that's the information you need. You need the numbers of each type of tree, in this case, present in the woodland, just the numbers. Okay, and those are the details that you come back with. And similarly, if you look at question 6 there, you can see they're doing a calculation for Simpson's index for different types of plants in 3 fields, and you can see what they've got. They really just got numbers of the different types of plants in each of the 3 fields, and then you go about using the formula there to calculate. So they've left you to calculate for field C. They've done the calculation for field A and field B. By the way, once you've done field C and worked it out, the answers for field C should be 0.33. And we'll have a quick look at how that's done. But just notice that they've given you the values for Simpson's index for field A and field B. As a bit of practice, what you should do is practice working out for field A and field B. See if you get the same value as they do. And you should do. So for field C, the calculation and what they're giving you there is the 5 species in field C, and they're telling you the number of each species. And the number that they've given you there, like for example, 2 common daisy, 1 dandelion, 5 buttercup, 15 white clover, etc., etc. That would represent the value n in the equation. And then you have to, on the top of the equation there, you'll see what you have to calculate is n on n minus 1. So for each of those species, you've got n for the common daisy. N minus 1 for the common daisy is 1, because it's 2 minus 1. So it's, and then you multiply n on n minus 1. So then you're multiplying 2 by 1 gives you 2. So essentially, I'm just doing the numbers here for the 5 numbers for field C. And if I do that quickly, what I've got, let's see if I can do that fairly quickly. So here's the, I'm not even writing the names of the species here. I'm just putting the numbers in for field C that's present there. So the numbers are 2, 1, 5, 15, 5, 2, 1, 5, 15, 5. And what I'm saying is that those values you get, I'm not writing the names of the species there, you've got the names of the species. Those numbers that you've got are the n's, the values for n. Next thing you need to do is do n minus 1. So 2 minus 1, that's 1. 1 minus 1 is nothing. Let's get a pen that writes here. So in your next column you've got 1. 1 minus 1 is nothing. 5 minus 1 is 4. 15 minus 1 is 14. And then 5 minus 1 is 4. So now you've got n and n minus 1. In the next column then you want to multiply n by n minus 1. You want to multiply these numbers. So 2 ones is 2. 1 noughts is naught. 5 fours is 20. 15 14s is 200. And you better just calculate a calculator. 15 by 14 equals 210, so it comes at 210 there, and then 5 fours is 20. 5 fours is 20. So you add those numbers up. So 20 is 230, 250, 252. So you notice in the formula it says the summation of. So the top of the top line of the formula is the sum of n and n minus 1. So it's simply adding those numbers up, which gives you 252. So your Simpson's index in the top of the equation is 252. And down the bottom is big N and n minus 1. Well, big N is the sum of all the little n's. So big N is the sum of these, which is 25, 26, 28. I think I've got that right. Big N is 28. 2 minus 3 and 5 is 8. 15 is 28. And then you have to multiply big N on n minus 1. So it's 28 by 27. So we're doing that calculation. 28 by 27 equals 28 by 27 equals 756. So 756. So your answer is 252 over 756. 252 divided by 756 equals, and comes out at 0.33. So that's your Simpson's index value. So practice doing those. And you'll see then of the three fields, how do you determine then which is the most diverse based on those Simpson's index values? Well, the nearer the Simpson's index value is to 0, the higher the biodiversity. Simpson's index values range from 0 to 1. So a Simpson's index value of 0.1 has got a greater biodiversity than 0.3, yeah, and so on. So you'll see from those fields there that field B has got the highest biodiversity because its value is 0.19, the others is 0.43 and 0.33. So that's the answer. Field B has the highest biodiversity. The answer is although field A and field B contain all 5 species, they're not considered equally diverse. So just notice that each of these fields has got all 5 species, but they're not all equally diverse. In other words, the value of Simpson's index is not the same for them all. In fact, the value for field A is 0.43, which is quite a high value for Simpson's index, indicating a lower biodiversity. And the question is, it says, explain why they're not equally diverse. And the answer essentially is that for the Simpson's index value to be as low as possible, the 5 species present there should be equal numbers of them. Should be an equal distribution, as it were, of the 5 species. And you can see that's the case for field B. The numbers, there's a sort of an even distribution of the 5 species. Whereas for field A, there's only small numbers of the first 4 species. And field A is dominated by ryegrass. So the answer to that question is whether or not equal diverse, you would say that field A has got 1 species which dominates. In other words, very large amounts of ryegrass, whereas field B has a more even spread of numbers of each of the species. That's the answer. Source of error in this investigation, misidentification of species was one of the answers, and also just miscalculation, a wrongly done calculation. Okay, so that's the Simpsons index, and that's quite a difficult one. Just relating that to the notes, you'll see that that's dealt with on page 14 and page 15 in the notes. So that's that question. I just want to briefly come back to the 5 kingdom classification system and say a wee bit more about it, because I've just noticed there's something else there that's relevant. And the thing that's relevant is that the 5 kingdom classification system has been about for quite a period of time. Well, let's say it wasn't about when I was at schools, that was about 50 years ago. So 5 kingdom classification system is relatively new, but of recent times there's been discussions about modifying it, having a different classification system, or changing the classification system in some sense or other. I'd ask, see your question there, Sean. I'll see if we can find this question. Somewhere there it asks a question that says, let's see if we can find the question. Yeah, question 2. 2C part 2, it says, suggest a reason why a classification of organisms can change. In other words, over time, scientists may decide that the classification system that they have is not appropriate, and they want to change it and come up with a slightly different classification system. And the answer to that question says, it's a consequence of new discoveries, new organisms being discovered, and new research that's done, maybe to show that new groups of organisms are not as closely related to each other as previously thought, or essentially new discoveries, new findings. I think I've answered that question somewhere. I said you might need a new classification system. So I'm referring you here to parts of the notes. I'm referring you to page 13. And page 13, I've used the heading there as alternative classification system. And essentially it's referring to modification of the 5 kingdom classification system that has recently been adopted. So the 5 kingdom classification system has recently changed or modified as a result of new knowledge. See, that would answer question 2C part 2. You could say new knowledge gained from advances in science, or new discoveries made in science. Most scientists now accept that we can put all organisms in three groups called super kingdoms. Now, the grouping super kingdom comes above kingdom. It comes above kingdom. And super kingdoms, you'll see them listed there. They are archaea. So I'm just writing them on the board. This might get asked about. So basically you have, well, one of the super kingdoms is eukarya. And this is the one that you most likely be asked about, eukarya. Eukarya, it's a super kingdom. The other word for super kingdom is domain. So super kingdom or domains above kingdom. The eukarya is a super kingdom, and it contains the 4 kingdoms, 4 of the original 5 kingdoms that were contained eukaryotic organisms. And if you remember, that was the Protoctista, the fungi, the plants, and the animals. And these are the 4, I just write. So these are the original 4 kingdoms from the 5 kingdom system. Protoctista, fungi, plants, and animals. And you remember they were eukaryotic. So this is the super kingdom up here. These are the kingdoms. So super kingdom or domain, and then you have the kingdoms. So within the super kingdom eukarya, you have those 4 kingdoms. And then what has happened is that scientists have taken the other kingdom, which was prokaryotic, and they've split it into 2 super kingdoms. One called bacteria, and the other called other referred to as archaea. So we now have 3 super kingdoms: bacteria, archaea, and eukarya. And these two super kingdoms are essentially the product of the original kingdom, Prokaryote. It was discovered that the original kingdom, Prokaryote, didn't easily allow all the prokaryotic organisms to fit into it, and so it had to be split into two groups, bacteria and archaea. And then eukarya then contains all the eukaryotic organisms. So what kind of question you get asked for this one? If you look at question 1b, 1b part 2, this is back to the question about the butterfly again. It says, state the domain for this butterfly. Domain. So domain, the other word for domain is domain or super kingdom. What's the super kingdom for the butterfly? Well, the butterfly, of course, is a kingdom animal. So its domain is eukarya. And that's most likely, if you get asked about these domains or super kingdoms, you're probably talking about this particular group here, eukarya. It contains that what we would be in eukarya, all animals, plants, fungi, and protoplasts. Okay, I think there are some other bits and pieces in the question booklet here, but they may relate to the adaptations topic or human impact on biodiversity. As I say, you tend to get threads of each of the three topics coming together in questions, on ecology questions. So I think I'll stop there, and hopefully it helped you with this particular topic. So there you are. Thank you very much. All the best. Bye.